Asteroids are fascinating to scientists because they tell the history of the universe. However, there is another reason that scientists pay close attention to them. They can collide with our planet, leading to catastrophic consequences. In fact, showing the seriousness of the situation, NASA chiefs have given serious warnings as asteroids are actually on their way to hitting the Earth. It is for this reason that NASA has set up the DART mission. Asteroids are rocky objects that orbit the Sun but are too small to be classified as planets. They're also referred to as planetoids or minor planets. There are millions of asteroids that range in size from hundreds of miles to a few feet. However, the combined mass of all asteroids is less than that of Earth's moon. Where are asteroids found? Asteroids are found primarily in three areas of the solar system. The majority of asteroids are located in a vast ring between the orbits of Mars and Jupiter. This main asteroid belt contains over 200 asteroids with diameters greater than 60 miles or 100 kilometers. This asteroid belt also contains between 1.1 million and 1.9 million asteroids larger than 1 kilometer or 3,281 feet in diameter, as well as millions of smaller ones. However, that doesn't mean that everything that you see in the main belt is an asteroid. For example, Ceres, once thought to be only an asteroid, is now classified as a dwarf planet. And over the last decade, scientists have discovered a new class of object known as main belt comets, which are small rocky objects with tails. While some tails form when objects collide with an asteroid and disintegrate, others may be comets in disguise. And where did asteroids come from? Asteroids are leftovers from our solar planet's formation about 4.6 billion years ago. Early on, Jupiter's birth blocked any planetary bodies from forming in the gap between Mars and Jupiter, causing the small objects that were present to collide and fragment into the asteroids we see today. What we know about asteroids keeps evolving. The Nice model and the Grand Track, two recent theories, suggest that the gas giants moved around before settling into their modern orbits. This motion could have caused asteroids from the main belt to rain down on the terrestrial planets, thereby emptying and refilling the original belt. Almost all asteroids are irregularly shaped, with the exception of Ceres, which is nearly spherical. They are frequently pitted or cratered. For example, Vesta has a massive crater 285 miles or 460 kilometers in diameter. Most asteroids are thought to have dust on their surfaces. Asteroids rotate as they orbit the Sun in elliptical orbits, sometimes tumbling quite erratically. More than 150 asteroids have a small companion moon, with some even anchoring two moons. There are also binary or double asteroids, in which two asteroids of roughly equal size orbit each other, as well as triple asteroid systems. Asteroids are cold places. The average temperature of an asteroid's surface is minus 100 degrees Fahrenheit or minus 73 degrees Celsius. Now, there is a category of asteroids that scientists pay close attention to because of their proximity to the Earth: near-Earth asteroids or NEAs. As the name suggests, NEAs orbit the Sun at roughly the same distance as the Earth. These objects are divided into subcategories based on how the asteroid's orbit compares to that of Earth. Amor asteroids, for example, have orbits that approach Earth's path but only travel between Earth and Mars, whereas Apollo asteroids have Earth-crossing orbits, but they spend the majority of their time outside of the planet's path. Arson asteroids also cross Earth's orbit but spend the majority of their time inside it. And Terra asteroids are near-Earth asteroids with orbits that are contained within the orbit of Earth. Certain near-Earth asteroids are also classified as potentially hazardous asteroids, or PHAs. These rocks are within 4.65 million miles, or 7.48 million kilometers of Earth's orbit, and are larger than 500 feet, or 140 meters across. Scientists discovered over 27,000 near-Earth asteroids as of 2021, and just under 10,000 of these have diameters greater than 500 feet. The idea of asteroids smashing into the Earth has been spun to death by movie makers. However, the reality is that asteroids are a real threat to our planet. They can cause serious damage or even wipe out life completely from the Earth. Actually, the Earth has had multiple hits from asteroids already. The Chicxulub event is one of the deadliest in the history of our planet. This asteroid, measuring 10 to 15 kilometers or 6 to 9 miles in diameter, collided with Earth some 65 million years ago in what is now Mexico. The impact wiped out 70% of all life on Earth, including the dinosaurs. An impact of that magnitude would have had catastrophic consequences, and the geological record provides some insight into what happened. The asteroid collided with water, causing mega tsunamis to rip through southeastern Mexico, Texas, and Florida, as well as up a shallow interior ocean that covered what is now the Great Plains. The blast would have thrown an asteroid into Earth fragments so far that they would have briefly left the atmosphere before falling back to Earth. All of this material, like millions of shooting stars, would have been heated to incandescence upon re-entry, heating the Earth's surface and igniting wildfires. It is possible that all of the world's forests were destroyed. Meanwhile, massive shockwaves would have caused worldwide earthquakes and possibly volcanic eruptions. As the impactor slammed underground in less than a second, a cloud of superheated dust, ash, and steam would have erupted from the crater. This dust would have covered the entire Earth's surface for up to a decade, creating a hostile environment for life. And perhaps more importantly, the dust could have lingered in the atmosphere for many years, blocking out the sun and disrupting the photosynthesis of plants on which the entire food chain depends, as well as cooling the Earth's temperatures. But even more powerful was the asteroid impact that formed the Vredefort crater, which is located in South Africa. This asteroid, at least 20 kilometers across, hurtled toward Earth about 2 billion years ago. The impact created a 40-kilometer deep and 100-kilometer wide crater on the surface. The crater widened and then shrunk almost immediately after impact as the rock below began to rebound and the walls collapsed. It formed the world's oldest and largest known impact structure. Scientists believe that Vredefort crater was between 180 and 300 kilometers wide when the rebound and collapse stopped. However, more than 2 billion years of erosion have reduced the opening to what you see today. However, the uplift at the impact center was so strong that it turned a 25-kilometer section of Earth's crust on end. The various layers of upturned rock eroded at different rates, resulting in the concentric pattern that can still be seen today. Based on revised calculations of the original size of the Vredefort crater, the Vredefort asteroid was likely twice as large as the dinosaur-killing Chicxulub. It could also have been traveling much faster, making its impact even more severe, potentially the single largest energy release event in Earth's history. It could have been traveling up to 56,000 miles per hour, or 90,000 kilometers per hour. However, the Vredefort impact, unlike the Chicxulub impact, did not leave a record of mass extinction or forest fires because there are only single-cell life forms and no trees 2 billion years ago. However, the impact would have had a greater impact on global climate than the Chicxulub impact. Now, not all asteroid strikes happened millions of years ago. In 1908, an asteroid or comet with a diameter of about 30 meters entered the atmosphere and exploded above ground in Tunguska, Russia. The explosion destroyed approximately 80 million trees over a 2,150 square kilometer area, or 830 square miles. This explosion was estimated to be 1,000 times more powerful than the Hiroshima atomic bomb explosion. If this had happened over a city, that city would have been completely destroyed. Fortunately, it occurred in a remote area of Siberia, and no one is believed to have been killed. And in 2013, an asteroid about 20 meters in diameter entered Earth's atmosphere above the Russian city of Chelyabinsk. It exploded while still in the air, releasing the equivalent of 500 kilotons of TNT. Fortunately, it exploded about 30 kilometers above ground and caused no direct impact damage. Nonetheless, it caused a shockwave that injured 1,500 people and damaged 7,200 buildings in 6 cities. The majority of these injuries were caused by curiosity. When people saw the bright flash, they went to the windows to look outside. The shockwave arrived later, traveling at the slowest speed of sound, and shattered the windows, injuring people with flying glass. But are we in danger of an asteroid collision as you watch this video? NASA has alerted us multiple times of asteroids hurtling our way. One of them is potentially hazardous asteroid 2001 CB21, a giant asteroid estimated to be 4 times bigger than the Eiffel Tower, and it's heading towards the Earth and is likely to make a close call. NASA has classified the asteroid as potentially hazardous because it will pass within 4.5 kilometers of Earth. While that distance may seem to be a lot on the cosmic scale, that is right in our backyard. The potentially hazardous asteroid is up to 1.3 kilometers or 4,265 feet in diameter. The asteroid was detected by the Virtual Telescope Project astronomer Gianluca Massi of Italy, and it was more than 21.5 million miles away from Earth. Another one is the asteroid 2022 AP7, which was discovered by an international team of scientists using a camera that was designed to investigate dark energy in the universe. 2022 AP7's orbit crosses Earth's path around the Sun, getting as close to the planet as 4.4 million miles, uncomfortably close by cosmic standards. As a result, the 2022 AP7 is the largest potentially hazardous asteroid discovered in the last 8 years or so. With a diameter of about 1.1 to 2.3 kilometers, 2022 AP7 is the largest PHA discovered since 2014 and is likely in the top 5% of the largest ever discovered. And here is where it gets scary. Any asteroid larger than 1 kilometer in size is considered a planet killer. If such an object struck Earth, the impact would be devastating to life as we know it, with the dust and pollutants being kicked up into the atmosphere where they would linger for years. The Earth's surface would cool significantly from sunlight not getting to the planet's surface. It would be a mass extinction event unprecedented in millions of years. So following the discovery of the asteroid in January, additional observatories studied its motion and other astronomers identified it in older images. This dataset indicated that it would not be visiting Earth for the next century and possibly much longer. But that does not mean we are safe. The gravitational pull of objects in the solar system, including our own planet, ensures that Earth-crossing asteroids do not continue to dance in the same pattern indefinitely. The asteroid 2022 AP7 is no different. This asteroid will become increasingly visible in the sky as it crosses Earth's orbit closer and closer to where the Earth actually is. However, because we are safe for many generations, the orbit of this asteroid is not its most notable feature. What is most interesting about 2022 AP7 is its relatively large size, because its discovery suggests that other elephantine asteroids obscured by the Sun's glare are still undiscovered. This is why astronomers looking for PHAs concentrate on rocks 460 feet across. There are probably tens of thousands of them, and only about half of them have been identified. NASA's tracker has also detected asteroid 2011 AG. This asteroid in question is considered potentially hazardous, and there were fears that it could impact the Earth sometime between 2040 and 2047. NASA estimates that the massive asteroid 2011 AG5 has a diameter of up to 250 meters. In comparison, an adult humpback whale can grow up to be 16 meters long. This means that the asteroid could be as large as just under 16 humpback whales stretched out from mouth to tail. Humpback whales, like most massive cetaceans, are extremely heavy, weighing around 40,000 kilograms. 16 humpback whales would weigh approximately 640,000 kilograms. While it's unclear how much asteroid 2011 AG5 weighs, it's most likely a little more than all of these humpback whales combined. What about speed, though? The average humpback whale swims at around 27 kilometers per hour, which is quite impressive. Asteroid 2011 AG5, however, speeds through space at around 9.92 kilometers per second, or 35,712 kilometers per hour. That is, it is approximately 1,322 times faster than a humpback whale. As an Apollo-class asteroid, 2011 AG5 usually orbits the Sun outside of Earth's orbit, crossing over when its orbit overlaps with Earth's, and this is why there are concerns that it would have an impact on the Earth. NASA's tracker also caught asteroid 2001 CB21, which according to measurements was the size of the Vatican City. Its width is estimated to be between 560 meters and 1.2 kilometers. In comparison, even at its smallest possible size, it would be significantly taller than the New York City's Empire State Building, which stands at 443 meters if going to the tip. Its maximum estimated size is greater than the length of the Vatican, which is approximately 1.05 kilometers. This asteroid has also been designated as potentially hazardous, meaning it's large enough and close enough to us that we should be concerned. If 2001 CB21 were to hit Earth, the results would be devastating, but how bad would it be? According to research from Israel's Weizmann Institute of Science's Davidson Institute of Science, an asteroid larger than 140 meters in diameter would release energy at least 1,000 times greater than the first atomic bomb if it collided with Earth. Something even bigger, like the asteroid Apophis, which is over 300 meters wide, could wipe out an entire continent. A kilometer-wide asteroid such as the 2001 CB21 could cause a global catastrophe. NASA continues to keep its eyes glued to asteroids. The space agency has launched a pioneering mission to study Jupiter's Trojan asteroids, two large clusters of space rocks thought to be remnants of the primordial material that form the solar system's outer planets. Lucy, a space probe packed inside a special cargo capsule, launched on time from Cape Canaveral Air Force Station in Florida on top of a United Launch Alliance Atlas V rocket. Lucy's mission is to study a record number of asteroids over a 12-year period. It will be the first to investigate the Trojans, a swarm of thousands of rocky objects orbiting the Sun in two swarms, one ahead of and one behind Jupiter's path. The largest known Trojan asteroids, named after Greek mythological warriors, are estimated to be 225 kilometers or 140 miles in diameter. The asteroids, which are thought to be rich in carbon compounds, may even provide new insights into the origins of organic materials and life on Earth. No other single science mission in history has been designed to visit as many different objects orbiting the Sun independently. In addition to the Trojans, Lucy will fly by Donald Johanson, an asteroid in the solar system's main asteroid belt, named after the lead discoverer, the fossilized human ancestor known as Lucy, from which the NASA mission takes its name. The Lucy fossil, discovered in Ethiopia in 1974, was named after the Beatles' song Lucy in the Sky with Diamonds. Lucy, the asteroid probe, will make history in another way too. It will be the first spacecraft to return to Earth's vicinity from the outer solar system, taking a route that circles back to Earth 3 times for gravitational assistance. The probe will maneuver in space using rocket thrusters and 2 rounded solar arrays, each the width of a school bus, to recharge batteries that will power the instruments contained in the spacecraft's much smaller central body. But apart from studying asteroids, NASA is upgrading its asteroid detection and tracking capabilities. The NEO Surveyor, a $1.2 billion telescope under development that will launch nearly 1 million miles from Earth and monitor a wide field of asteroids, has been hailed as a massive upgrade to NASA's detection arsenal. It is far better than today's ground-based telescopes, which are hampered by daytime light and the Earth's atmosphere. The new telescope will help NASA meet a goal set by Congress in 2005, which is to detect 90% of all asteroids larger than 140 meters in diameter, or those large enough to destroy anything from a region to an entire continent. However, NASA has fallen years behind its congressionally mandated completion date of 2020. Last year, NASA proposed a 3/4 cut in the telescope's 2023 budget and a 2-year launch delay to 2028 to support higher priority missions elsewhere in NASA's science portfolio. Asteroid detection garnered more attention after NASA slammed a refrigerator-sized spacecraft into an asteroid to test its ability to knock a potentially hazardous space rock off a collision course with Earth. NASA's Double Asteroid Redirection Test, or DART mission, was designed to test the kinetic impactor technique for deflecting an asteroid for planetary defense. DART slammed into a small asteroid Dimorphos to change the moonlet's orbital speed. The DART mission was launched from Space Launch Complex 4 at Vandenberg Air Force Base in California atop a SpaceX Falcon 9 rocket. The mission exemplifies the high level of international collaboration required for such a large-scale undertaking, as scientists and engineers from all over the world contributed. The binary asteroid system Didymos, which means twin in Greek, was DART's target. Didymos, a near-Earth asteroid measuring 0.48 miles or 780 meters across, and its moonlet Dimorphos, measuring 525 feet or 160 meters across, comprise the system. DART purposefully collided with the moonlet Dimorphos at 4.1 miles per second or 6.6 kilometers per second. That is a whopping 14,760 miles per hour or 23,760 kilometers per hour. An impact at this speed should theoretically have changed the moonlet's orbital speed by a fraction of a percent, enough to change its orbital period by several minutes. The change in Dimorphos' orbit around Didymos was observed and measured by telescopes on Earth to determine whether the mission was successful, according to NASA. And last October, NASA officially announced that DART cut Dimorphos' nearly 12-hour orbit by 32 minutes, shattering previous estimates. DART was a straightforward spacecraft. The main vehicle measured about the size of a refrigerator. When fully deployed, each of the two large solar arrays measured 27.9 feet or 8.5 meters in length. The Didymos reconnaissance and asteroid camera for optical navigation was the only instrument aboard the DART spacecraft. Of course, if your primary goal is to collide with an asteroid, you don't need to bring much. After launching on a SpaceX Falcon 9, the DART spacecraft deployed its rollout solar arrays, ROSA, to power itself for the journey to Didymos. The ROSA arrays were tested on board the International Space Station and were deemed suitable to provide the power required to support DART's electric propulsion system. As part of its in-space propulsion, the DART spacecraft used the next-generation fuel-efficient NASA Evolutional Xenon Thruster Commercial, or NEXT-C, solar electric propulsion system. DART was guided to its destination Dimorphos by advanced autonomous navigation software. As you can imagine, finding a target 525 feet, 160 meters in diameter, and 6.8 million miles or 11 million kilometers away from Earth is no easy task. The navigation software was designed to recognize and distinguish between Didymos and Dimorphos, allowing the DART spacecraft to be directed to the smaller body Dimorphos. As the spacecraft approached its target, an onboard high-resolution camera, Draco, assisted in navigating the DART spacecraft and measuring the target asteroid, including Dimorphos' size and shape. Draco is based on NASA's New Horizons spacecraft's LORI camera. DART successfully collided with Dimorphos in September in what NASA called the world's first planetary defense test. The crash went off without a hitch, so engineers didn't have to resort to one of the 21 contingency plans they had prepared just in case. The final 4 hours of DART's approach were mostly automated, with the spacecraft's navigation system locking onto Dimorphos in the final hour. The DART spacecraft's main camera sent a photo to Earth every second until the feed went dark as the spacecraft collided with the asteroid. Photos taken by DART during its final moments revealed stunning details of both Didymos and Dimorphos. The moonlet had never before been seen. It was revealed by DART to be a strange new world, an egg-shaped asteroid covered in boulders and uneven terrain. LICHA-CUBE, or Light Italian CubeSat for imaging asteroids, joined the spacecraft. LICHA-CUBE is an Italian space agency-contributed CubeSat built by the Italian aerospace engineering firm Argotec. The tiny CubeSat weighs only 31 pounds or 14 kilograms and is about the size of an adult's hand and forearm. It has 2 optical cameras and followed DART to Dimorphos before settling in to watch the collision from a safe distance of about 600 miles away or 1,000 kilometers. LICHA-CUBE's role was to observe the impact and help confirm whether the experiment was successful. However, it took weeks for the images it took to be returned to the Earth. And as a follow-up on DART, Hera is a post-impact investigation mission planned by the ESA. The spacecraft will launch in October 2024 and arrive at the Didymos binary system in December 2026. 2 CubeSats will join the ESA's Hera spacecraft. They will survey both Didymos and Dimorphos, paying special attention to the crater left by DART's collision with Dimorphos. The Hera mission also aims to determine the precise mass of Dimorphos. Though DART and Hera are designed and operated by independent space agencies, their collaboration will advance our understanding of planetary defense technologies. Let's hear what you think about asteroids hitting the Earth. in the comments section below.